friends. So we learn now the uniformly accelerated motion in one dimension. Okay. So what do we mean by uniform? Uniform means uniformity in anything means that whatever change is happening, the same amount of change happens in the same amount of time interval. Okay, that is uniform. Okay, in equal time interval, equal changes, if it happens, then we say the change is uniform. Okay, and what is acceleration? Acceleration is simply the change of velocity with respect to time. So that means if the change of velocity is same in same time intervals, okay, that means the acceleration is uniform. Okay, so okay, now let's take, we are discussing one dimensional motion. Whatever the motion is happening is along this line. Okay, whether it will be in the positive direction or it can be in the negative direction. Okay, for now let's suppose something, a body is moving only in the positive direction for simplicity. Okay, we can then generalize to both the direction or even 3D also. Okay, so but for now just assume that the motion is towards the positive direction. Okay, so if the motion is positive direction, that means the velocity is positive. Okay, so that means the, if I simply say speed, given that the motion is only along the positive direction, the speed, the velocity is positive. So now speed is the same as velocity if the direction has been given that it is positive only. Okay, now fine. So if something is moving with a fixed speed, let's say 5 meter per second. Okay, so this is the speed of something. In 10 seconds, how much it will move? 5 meters in every second it moves. So in 10 seconds it is going to move 5 into 10, 50 meters, right? So that means if the speed is not changing, this is how we simply find out the distance, or the displacement also it's the same because the direction is positive only in our case, right? So this is uniform speed. Okay, why uniform speed? Because in any time interval, speed is what, the change of displacement or distance in this case also. So speed is the amount of change of distance is the same in equal time interval, then we say the speed is uniform, right? So 5 meter every, just take any 1 second, the distance traveled will be 5 meter only. That's why this is a uniform speed. Okay, now if the speed is changing, okay, and mind it, here we have taken our acceleration, the velocity to be in the positive direction. There is no movement along the negative direction. So speed is the same as velocity. So don't get confused. Okay. Now let's say the speed is increasing. Okay, increasing at a rate of 2 meter per second. This much change in speed happens every second. Okay. So this is the acceleration, right? This is the acceleration. Acceleration is what? Magnitude wise, it is the change of speed, amount of change in the velocity or the speed in a unit time, right? So 2 meter per second worth of change happens every second, right? Okay. Now, how to find out the distance it will travel in any given time? If you have to find that, what to do? So first we'll try to find out what is the speed at any given time. Okay, because the speed will change. Okay, so let's say initially starting at time t is equal to 0, something was at rest. That means the speed was 0. Something, some car was there. Let's some person was here. Let's say a person was here standing at this 0 mark at time t is equal to 0, and he was at rest. Okay, now he starts accelerating. That means his speed will increase with this rate 2 meter per second, worth of change happens in his speed, right? Okay. Now first we'll try to model how much is the speed at any given time, right? So just see, in 1 second, in 1 second, the speed is will become 2 meter per second, right? In half second, let's say after half seconds, how much is the speed going to be? It is going to be half of 2, right? Because I told you in equal interval of time equal change will happen. So if in 1 second the speed increases by 2 meter per second, in half second the speed will increase by 1 meter per second, right? So speed at any given time for this case will be given by what? 2 into the time interval, right? Simple unitary method, right? 2 into the time interval from the beginning, right? T, if t is the time of any moment, minus initially the time was 0, or you can say simply 2t. Okay, so speed at any given time is going to be 2 into the time. Let's say I ask, if time t is equal to 5 seconds, that means after 5 seconds from the beginning, what is the speed going to be? The rate of change or increase of velocity is same. So in 1 second the change is of 2. Okay, so if any in 5 seconds it is 2 into 5. After 3 seconds it is going to be 2 into 3, because every second there is increase of 2. So after t seconds the increase will be 2t. Simple. So that's how the speed is 2t. And let's assume this boy was already having some velocity initially. If it was not 0 but rather something, let's say u velocity, initial velocity was already, it was moving, let's say with some speed, let's say 2 meters per second, it was moving with initially only. Okay, so after t seconds, how much is the speed going to be? Initially plus the change, right? So 2 meter per second was the initial, and the change has been worth 2 into t, right? So basically I want to say is key the speed after t time from the beginning is going to be u plus at. V is the final velocity, u is the initial velocity, a is the acceleration, and t is the time interval. Time interval, right? V final velocity is equal to u plus at, right? So what is happening? The change is linear. Okay, this is a linear change in speed. Okay, if I draw the graph of velocity with respect to time, it is going to be like this. If I make the graph of velocity with respect to time, the velocity is increasing uniformly. If I make the graph, it is going to be like this. Let's say initially it was already something u. Okay, this was, this is in, let's say, meter per second, and then it increases like this in a straight line from here. Okay, so this is the velocity time graph, right? At any time, at any time, what the velocity is going to be? This u, this is what, this is u only, right? And this is the change, this is the at part. U plus at is the velocity at any given point, at any given point. at any given time t vt, that is u plus at. U plus at is the total velocity. Okay, why is that thing at? This is acceleration into time. Why? Just see, this is what, this is the change in the velocity, isn't it? From the beginning, this was the velocity was already u, and the velocity at the time, at this point t naught, if we are trying to, at any point t naught, if we are trying to analyze, so this much is the change from the beginning, right? What is the definition of acceleration? The change of velocity changes. So this is delta v. This is what? Time interval that is elapsed from the beginning. So delta v by delta v upon delta t is what acceleration is. So what is delta v? A times delta t. Delta t here is what? T naught minus 0. Initially here the time is what? 0. Here t is equal to t naught. So the time interval is delta t. So like this, a into delta t is the change in the velocity or the speed, and plus u. Okay. Now we try to find out the distance it will travel. Okay, distance it will travel. For that, again we have to understand one simple thing that we already know. Again, take the coordinate axis. Take the coordinate axis, y axis, x axis. Okay, we are trying to find out the distance a body travels when moving with constant acceleration. Okay, so for that, to understand that, okay, we already have this formula that velocity at any point t is initial velocity plus acceleration times the acceleration into the time interval. Okay, now what is the formula to get the area of a trapezium? Area of a trapezium is obtained by, let's say, this, and okay, this is a trapezium. Okay, now let's say this is h1, this height is h2, and this is, let's say, b, base of the trapezium. Okay, just say b is the length of that base, h1 h2 are the heights of the two sides as shown. How do we find the area of this trapezium? Okay, so basically what we do, we assume, we say that we take the average of h1 and h2 and assume that, means we draw an equivalent. If we take that this is equivalent to the area of a rectangle with the same base b, what height should we take? What should be the height h naught, let's say h naught of this rectangle, so that these two have the same area, this rectangle and this trapezium. So the height that I should take is the average h1, sorry, this is h2 plus h2 upon 2. That means just the midpoint of these two, h1 plus h2 upon 2, somewhere here like this. So if I take h1 plus h2, the arithmetic mean, okay, this, if I take h naught, okay, this h naught, then it will give me the area. Okay, so this rectangle with the same breadth h naught and base, same base b, has the same area as this trapezium. Okay, and that is the formula we know, h1 plus h2 upon 2 times v is the trapezium. This is how we have been finding the area of the trapezium, right? Okay, So in the case of uniformly accelerated motion also, okay, what happened? The speed versus time graph, if it is given, let's say initially it had some speed already, let's say 5 meter per second, and then the speed increased in a straight line manner uniformly, okay, and it became, let's say, 13 meter per second, okay, 13 meter per second, and the time interval is, let's say, 4. At this point, time is 4 seconds, okay. What is the displacement that is happening? Initially it was traveling already with the speed 5 meter per second, the speed became 13. So if I have to find, so what is the formula to find the distance? Speed into time, right? But the speed is not the same at any time, right? Just take, let's say, this point, the speed is how much? This much. If I take this time, the speed is something else. Any point of time, the speed is never the same, it's always increasing, okay. No 2 point of time the speed is, then what time to take to find out the distance, okay. Should I take it 13 meter per second into the time interval 4, or 5 meter per second into 4? What? An average is taken, okay. So like the same thing, because what is happening here, this is the small distance, the small velocity here into this time interval delta t. Is the sum is the displacement or the distance in that time interval. Similarly, small trapeziums, if you add up, you get the whole thing, isn't it? For uniformly, what we do, average of the initial and final gives you the average velocity. Average velocity. So you assume that average velocity v initial plus v final upon 2 to be the average velocity for the whole journey, and you take this to be like the constant speed, an equivalent speed, a fixed speed, okay. So in this case, initially it was 5, then 13. So what is the average? 13 plus 5 is equal to 2, that is 9. So 9 meter per second you can take to be a constant speed, equivalent, it's not the same thing, equivalent. It's like saying he had the body been traveling with the speed of fixed speed of 9 meter per second for this 4 seconds of time interval, starting from the beginning, it will travel the same distance, okay. A body starting from 5 meter per second square, uniformly accelerating to a speed of 30 meter per second square in a span of 4 seconds, will travel the same distance as a body traveling with a fixed speed of 9 meter per second for 4 seconds, okay. That is the idea of the whole thing, right? So to generalize this, what we can do, we know that final speed is u initial speed plus acceleration into the time interval. I'm simply writing t, because initial time is 0, the time of observation when you started observing, you will take that to be 0, okay. T is equal to 0. So instead of writing delta t, I'm simply writing t. You can write delta t also, that is also not bad, okay. And then we found out that the distance it will travel is what? So the distance is what? The average speed for uniformly accelerated motion. What is the average speed? V average is taken as V final plus V initial upon 2. So what is V final? This is V final, right? V final, V initial. So V initial we have taken as U. V final we say simply V, okay? So this is V plus U upon 2, isn't it? This is the first equation of motion, right? I can plug the value of V here, you get U plus AT plus U upon 2. So that is what? U plus, yes, U plus AT, okay, fine. AT by 2. So this is the average speed of a body that is accelerated uniformly, okay. This much you can take to be the average speed for the whole journey. Okay, this is not the actual speed, it is different at all times, but for a time interval, for a considerable time interval, this can be assumed for calculating the displacement or the distance if they are traveling in the same direction. Fine, I hope you understand this. Now, what is the distance? Okay, if I say that this can be taken to be the average of the whole, so what is the displacement? Displacement is the same as distance. Here, to for understanding, we are taking it is traveling in the positive direction only. Okay, so simply the average speed for the whole journey into the time. So the time interval into the average speed, that is what ut plus half at square. So this is your second equation of motion. Ut plus half at square is the distance traveled in if some acceleration. If something is moving with uniform acceleration, this is the expression to get the distance. And if you put everything with their respective signs also, you get the displacement actually. You get the displacement. Okay. So this is the expression for displacement. Okay. So we have our two equations of motion. What were they? First one was V is equal to U plus AT. First one. Second is the displacement is given by UT plus half AT square. This is the second one. Okay. Now, if you simply eliminate t from these two, take out the value of t from the first one and plug it into the second one, you get the third equation. V square is equal to u square plus 2 times a into the displacement. So, this is the third equation of motion. This is the third equation of motion. These three equations of motion we have find. This is for one dimension uniformly accelerated motion. These two things are very important to note for one dimensional motion and uniformly accelerated motion. Uniformly accelerated motion. Very important to note. Okay, fine. Thank you.